Alright, so here I want to go over some of the questions on our worksheet. So let's write down the electron configurations. We have the order. So we have 1s, we have 2s, we got 2p, 3s, 3p, 4s, 3d, 4p, 5s. Alright, and then 4d, 5p, 6s. So well, this order will be provided, okay? So you will be provided this order, so we will know which electrons that we are going to occupy and what orbitals. And also we know that S orbital can hold 2 electrons, p orbitals can hold 6 electrons, d orbitals can hold 10 electrons, and f orbital can hold up to 14 electrons. So based on this information, let's work on these problems. Question number 9 here. So which of element has the following ground state electron configuration? So here I see that 2s, 1s2, 2s2, 2p6, and 3s2. So this is exactly like this, right? 1s2, 2s2, 2p6, 3s2. This is what I would do. This is what we would do if we are writing down the electron configuration that's provided here. So let's see how many electrons we have on this atom. We have 2 plus 2 plus 6 plus 2. So total of 12 electrons, right? We have 12 electrons. So it's saying that ground state, it means that it's not excited. So electrons are not excited, as well as no charge on it, right? It doesn't say any charge. So we are looking for an element, a neutral element, which has 12 electrons. Okay. What would it be? That's going to be magnesium, right? So magnesium has 12 electrons. Okay, so here I want you to go over more with this electron configurations. Here I'm going to erase these ones. All right, so here if you want to put 2, it's going to be helium, right? If you fill these orbitals till 10, this is going to be neon. You can look up neon. 10 has 10 electrons. If you put 2 more, it's going to be magnesium. If you put 6 more, it's going to be argon. Okay, so in our periodic table we have noble gases, right? And if you fill the electron configurations up to this one, this is argon. All right. And if you have krypton, so it's going to be 2 here, 10 here, 6 and 2. That is krypton. Okay. This adds up to 36. All right. So instead of writing, for example, for magnesium, instead of writing all the way to the right here, like so for magnesium is 12, 2, 4, 6 makes total 10, and then we have 12. So instead of writing electron configurations of magnesium like this, 1s2, 2s2, 2p6, and 3s2, we can write down this part as a noble gas, neon, like this, square brackets. So magnesium, the configuration will be a neon, which we know that is 10 electrons, and then we know the configuration, and additionally we get 3s2. Why we are doing this? Because some atoms, they have a lot of electrons, so it's going to be easier to write down with using a noble gas. So let's do another problem here. I'm going to go up to this question. All right, I have question number 7. Also, I have the configurations on the bottom here. It's going to be easier to see. I'm going to erase these ones, okay? All right, so it's saying that which ground state atom has the electron configuration described following orbital diagram. Here is provided to argon, and argon has 18 electrons, right? So 2, 4, 10, 12, 18. This is argon. And also I got 4s right there, 3d, 4p. Okay, so let's count how many electrons we have. We've got 2 for 4s. And then we have 10 for D, and then I got 4 for P. So let's count total how many electrons we have. We have 18 from argon, and then we got 2 for S, it's 20, 34. So I'm looking for an atom with 34 electron, and that's going to be selenium from periodic table. Okay? So selenium has the electron proton number is 34. So I know that if an atom has 34 protons, we'll have 34 electrons, and here's his ground state. So that's going to be it. Okay, So let's do question number 8. So question 8 is asking how many unpaired electrons does a ground state atom of sulfur? Sulfur is S. I'll look at the periodic table, has 16 electrons and 16 protons. So what I'm going to do, I'm going to write down the configuration. 1s, 2s, 2p, 3s, 3p. I think that's going to be enough. So we got 16 electrons in here. Let's fill it in. I know that I can put 2 electrons on the s. I can put 2 in here. I can make 6 in here for p. I got total 10. And I get 12 in here. And I get 4 left. I'm going to put on the 4. P orbitals can hold up to 6, but I have only 4 left. I'm going to put just 4. And I'm going to erase this 4s in here. So this is going to be the electron configuration. So let's put boxes so we can see are they paired or unpaired. So here, this is paired. I got 2 electrons on the s. And then I have 2p here, 6 in there. I got 3s, 2 in there. I have 4. All right, so according to Hans rule, we're going to put the parallel first, and then we're going to pair up later, right? So I get 4 electrons in here. I'm going to do up, up, up makes 3. I have 1 more, so I can do pair up, 4. So I have here 2 unpaired electrons. So if you have an unpaired electrons on an atom, it's called paramagnetic. If you don't have any unpaired electrons like this, like noble gases, so it's going to be a diamagnetic. Diamagnetic. No unpaired. If no unpaired, diamagnetic. So we are done with 7, we are done with 8, we did 9. Let's talk about 10. Here we got cobalt. It's asking electron configurations of cobalt, ground state cobalt, and cobalt has 27 to a periodic table. What I'm going to do, I'm going to write in the configurations, which is on right here. I can just copy down 1s, 2s. I do not put the electrons now because I want to write the configuration, so I will fill the electrons later. 2p, 3s, 3p, 4s, 3d, okay, and 3d, and 4s, and 3d, 4p, 5s, 4d. It might be enough. So we got 22 electrons, right? I'm going to put 2 here, 4, 10, 12, 18, 20, and 7, right? I don't need these. Okay, so that's going to be the configuration. So when I look at the answers, they are described by a noble gas. So I'm going to have the argon right here, right? Argon has right here 18 electrons. So this is argon. So I can simplify this one as argon and 4s2, 3d7. So which one is this? A. Okay, so let's do question 11. Which of the element has the following ground state configuration? I have the krypton in 5s1 and 4d5. Well, here for this question, krypton has 36. For s, we got 1, and for d, we got 5. So we have krypton 36 plus 6 is going to be 42. And then here, this is molybdenum, right? This is the answer is molybdenum. But there's something weird here because when you write down the configuration, you would do like krypton 5s2 4d4, right? That's what you would do. However, there's some exceptions because atoms wants to have half filled or full filled. So let's draw here 1, 2, 3, 4, 5. So if you write this way, it's going to be 5s2. This is the regular way, the way we would do. This is it. So here, this atom has just need 1 electron to get half filled. So instead of getting an electron, this atom will reorganize the electrons. It's going to have this krypton 5s1 4d5. So for the 5s is half filled, still happy on this. D orbital will be half filled as well, so happy. So this is 5s1, this is for I'm sorry for this, so for the 5. So there are some exceptions, and atoms wants to move some electrons on higher shells, but you are not responsible to know that, okay? So you are not responsible to know those exceptions. So I want you to work with the regular way all the time, okay? So this is question 11. I'm going to erase this one. So let's do question 12. Question 12 is asking how many electrons are there in the second principal level of phosphorus. And phosphorus has 15 electrons. So let's do phosphorus 15. I have 1s, 2s, 2p, 3s, and 3p. I got 2 here, 6 here, 10, 12, and 15. So it's asking, that's the configurations. On the first shell I got 2, on the second shell I got 2 and 6, and the third shell I got 2 and 3. It's asking how many electrons are there in the second principal level. It's asking how many electrons on the second shell, right? So this is the first shell, this is the second shell, here's the third shell. So it's asking how many electrons in here. So 2 plus 6, total of 8 electrons. All right. So let's do 13. It's a ground state of vanadium. It's 23. 1s2, 2s2, 2p6, 3s2, 3p6, so 2, 4, 10, 12, 18, 4s2, 3d, that's 20, and then we have 23. Okay, so it's asking how many atoms in here. How many atoms unpaired electrons? So here 1, 2, 3, 4, and 5. So we have 1, 2, and 3 electrons unpaired, right? Because all the rest are paired. This is the only one that's not paired. Okay. 14. How many electrons in a ground state of cadmium? Cadmium here has 48. It's going to be a long electron configuration. Well, it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, okay, ss, ps, psd, 4p6, and 5s2, 4d10, 5p6, and 6s2. Let me see how many total now. 10, 12, 18, 20, 36, 38, 48. Oh, that's a lot. I'm just going to stop here. So 2, 4, 6, 10, 12, 18, 20, 20, 30, 36, 38, 48. That's what I have. All right, so it's asking how many, so ground state cadmium atom orbitals ml minus 1. So ml minus 1, ml I have 0 for s, so I don't have any ml minus 1 here. I don't have any ml minus 1. For p orbital, I have ml plus minus 1 and 0, right? So there's 2 electrons in here. I'm sorry, not this one. 2 electrons in here. I get 2 electrons on here. I got 2 electrons on the d orbital because I got ml minus 2 minus 1, 0 plus 1 plus 2. So I have one orbital where we can put 2 electrons on the d. I got 2 here for f, and then I got 2 for d. So 2, 4, 6, 8, 10 total. Okay. So for the phosphorus, how many electrons are there in the third shell? Well, on the third shell, phosphorus over here is going to be 5 electrons, right? So right there is 5. So I can record up to 15 minutes, so I'm going to stop it here, and I'm going to leave you guys with these 2 questions. Okay?